Hello, computer science geeks. We are starting Unit 9, Chapter 9 in this book of building Java programs. In this unit, some very cool and also some mystical stuff that you're going to learn. We're going to learn inheritance, overrides, superconstructors, casting to classes, and a very odd and difficult thing to quite understand entirely is polymorphism. Also in this chapter is interfaces, but because that is not in the AP exam, we will not be covered in this class, at least not right away. We will save that for later. All of this has to do with object-oriented program, OOP, object-oriented program, for which there are four major things that you need to have in there: encapsulation and abstraction, which are almost impossible to extricate from each other. You don't really know where one ends and the other begins, so oftentimes they just pull those together. I am not going to get too much into it. We're just going to say encapsulation. And then there's also inheritance and polymorphism, which we will do at the same time in this chapter. So when we're done with this chapter, you will know object-oriented programming, at least know about it. Mastering it is another story entirely. All right, so for today, though, we're not covering the whole chapter. Today, we're just going to cover inheritance, overrides, a new extend keyword, and we're going to add to your vocabulary superclass, subclass, and override. Okay, and this stuff is super cool. Superman here is supposed to be my, oh look, no, that's right. Inheritance, he's supposed to be the superclass, and then these serfs down here are supposed to be my subclass. And of course, as you know, I love Monty Python, so that's why they're there. So where to begin? Let's begin with the software crisis. Once upon a time, there was software, and people were really cool at building software, making it go, and the projects got bigger, and they got more people, and they needed more features and more code, build on. They had scaffolding on top of scaffolding with more code on top of more code, and in the end, what do you think they ended up with? Not success. Okay? The people were smart, just as smart as the people who started out in the beginning, and their features were cool, and they were adding more code, so why did they not have success? It's because it's hard. Computer science is hard. And so there's this popular book called The Mythical Man Month. And inside of there, the author talks about why creating software is so difficult. So for example, one of the contrary things that the author says is that adding manpower to a software project that is already late will contrarily and surprisingly make it even later. So you can't fix a project by just adding more people. Adding more people adds complexity. You add complexity, and the amount of time it takes to talk with one another just totally outweighs the benefit of making things go faster. Not only that, the complexity will make the code harder to get correct. You'll have redundancy, you'll add more bugs. It's just an utter disaster. He also talks about how when you try to fix bugs, especially late in the project, it sounds funny, especially late in the project, but to a complex system, that you are very likely to introduce other bugs. Not only that, you're very likely to introduce even more bugs. You fix one bug and you introduce two bugs. That's what happens in a very complex system. So you guys know the 99 bottles of beer on the wall song? Well, here's a cute little rendition of that. 99 little bugs in the code, 99 little bugs. Take one down, patch it around. 127 little bugs in the code. And that's basically, cute. I didn't invent it. But that's kind of what happens. And lastly, to fix this problem, we must realize that there is no silver bullet in here whatsoever. There's not just one small thing to achieve simplicity, productivity, and reliability. There's a lot of things that we need to do. Computer science and software engineering covers how to get closer and closer to this, but there is no panacea. There's no way to get to this, but I'll tell you that there's one thing that we are going to do, and we're going to learn object-oriented programming. So before object-oriented programming, everything was built inside of the same global space. And so when you build everything in the same global space, what happens is that everything has the possibility of interacting with everything else. So if you make a small mistake, what you're likely going to have is something like a house of cards. So let's see what a house of cards looks like. When the top element falls, so does the rest of the house. And if you're lucky, maybe the bottom part will remain standing, but you basically got to start over. So building software is a lot like building a house of cards. And so what we need to do is we need to protect ourselves. And instead of building everything in the same infrastructure, we start to encapsulate things and build things in objects. So we introduce object-oriented programming, OOP. Yes, OOP, O-O-P. People say OOP, but it's not alley-oop, which I never heard of before until I looked up. I was trying to find a picture of OOP, and this is what I found. Alley-oop. He's the comic book ape. So yeah, object-oriented programming. It's a tough concept. It takes a lot of time to learn, a lot of practice. But today we're just going to really figure out code reuse and some overrides. We're also going to do some overrides. So how does that work? Code reviews. So we're going to do an example. I'm going to bring in the employee class, and this is how it's going to go. Let's pretend that there's a law firm. I know you don't believe me, but let's just pretend that there is a law firm, and everyone in this law firm is an employee. Okay? They all have hours that they work, they have vacations, they have benefits, and even though that they have lawyers and secretaries and marketers and legal secretaries, they're all employees, and they're treated just slightly differently. Everyone's equal, but some are more equal than others. Okay, so let's figure out how it is. We're going to say that an employee works 40 hours a week, and employees make $40,000 per year. That's $1,000. What is that $1,000 per hour per week? Well, you know what I mean. If you extend it out through the whole year. Legal secretary is going to make $5,000 extra for the year and make a total of $45,000. And marketers are going to make even more, $10,000 extra per year for $50,000 total. Now, each type of employee has some unique behavior. For example, lawyers also know how to sue. Secretaries know how to take dictation. I know you're thinking, what the heck are you talking about? This is a very antiquated concept. I know you're thinking, what the heck are you talking about? What the heck is antiquated? Okay, there was once upon a time when people would talk, like I'm talking now, and other people would write down what they say. That's called taking dictation. And so once upon a time, back in the old days, they had secretaries that would listen to the boss, and the secretary would write down what they say, and then they would type it up into a mimeogram, and then they would duplicate it and send it out as a memo. I know, weird stuff. All right, and then we have legal secretaries who know how to prepare legal documents. Where are we going with this, Mr. Stride? Where are we going? All right, let's look at the employee class. Okay, so far I've introduced it. We got the public class employee, and they work hours. How many hours do they work? Well, hey, they just work 40 hours per week, okay? So that's what it says in their 20-page manual for this employee, that they get to work 40 hours per week. Awesome. When they get their salary, they're going to return the salary, $40,000. And when I ask it for how many vacation days, when I ask this employee object how many vacation days it gets, it's going to tell me that they get 10 vacation days per year. Now notice these are all properties on the employee class, yet there's no instance fields on this because I don't store these in any instance fields. We just have the properties get hours, and there's no way you can set it. When I code it, it's 40 hours. That's it, done deal, okay? You're not going to tell me later on that you're going to only work 20 hours per week because you're tired or something. You have to work 40 hours per week. So what you're going to do is you are going to look at this class, and I want you to implement the secretary class. So if you can recall, secretaries can also take dictation, okay? So you're going to pause. You're going to write the secretary class. All right, how many of you wrote code like this? This is a very standard answer. What you did is you took the secretary class, you copied everything from the employee class to get the hours, get the salary, get the vacation days, and then you said, well, the secretary just does one added thing, which is to take dictation, right? So I know I didn't really give you the method prototype for that, but a take dictation says, here, listen to this string, this text that I send in, and then you're just going to print it out, all right? You like that? You like that code? Maintainable? Lovely stuff, right? Well, this is what we used to do before we had object-oriented programming with our ability to inherit code. So wouldn't it be nice? Wouldn't it? It'd be so cool if I could write code like this, where I say public class secretary, And I want you to get all the contents from the employee class for free. And then just add this extra thing here, okay? Not only do I want you to get it for free, not only do I want to get it for free, but any maintenance on that code I also want to get for free. I never want to touch it, never want to see it. I just want it to work. Yes, we can do that through inheritance, okay? Inheritance is where children go to their parents and they get things from them for free. Of course, they have to die first, but that's life, or that's death. Here's how we do it. We go to our secretary class and we use this fancy schmancy new keyword called extends. So we put extends here that says, hey, I'm going to be a class that's going to be even better than the employee class. I'm going to take the employee class and I'm going to extend it. I'm going to get everything from the employee class for free, and I add this take dictation. So take dictation, same method, everything else is in there for free. If you were to run this code, it would work. It would, well, you'd have to have a main, you do stuff with it. But it gets all those methods. The secretary class inherits get hours, get salary, get vacation days. Those are the methods that come from employee. It inherits those methods for free. And then all we did was add a new method to extend the behavior of the secretary class. Very cool, right? So we have inheritance. It's a way to reuse code, and you get to share the code. You can have one class extend the behavior of the other, okay, and doing everything that we possibly can. So the superclass, let's look at it some more. We're gonna talk about this stuff here in a second. So here is syntax Yoda. This is how you do it. You do public class name extends superclass. Okay, so that's the generic way of doing it, and here's our example. Here's our picture. Let's get into our law firm employee class diagram, okay? So I have my employee, I have a lawyer, secretary, marketer, and legal secretary. And what these lines mean is that a lawyer is an employee, a secretary is an employee, a marketer is an employee. That would mean that I would have, just like I had before, public class secretary extends employee, okay? Here I would have public class legal secretary, and legal secretary would be a secretary, and legal secretary would extend secretary, which extends employee. So what we have here is that all of these are employees. Everything where there's a path from legal secretary up to employee, you can say that they are an employee. This legal secretary is an employee, and it also is a legal secretary. These lines represent the is-a relationship. So legal secretary is an employee, okay? So that's both super and subclass. What am I talking about? So the employee class is the superclass, okay? It is at the top. It is the superclass. We draw the superclass at the top, and all the arrows go up to it. And all the other classes are the subclasses of employee. So the superclass is up on top. All the subclasses go down below. All of these are subclasses of employee, okay? All of these are subclasses of employee. Are you saying, wait a minute, Mr. Star, wait, I'm talking to my dog, not you guys. Wait, okay, good boy. Subclasses are better? Is that what you're saying? They're better because they extend? Well, kinda. It's almost a misnomer. The only reason why they're called superclasses is because they're on top. The subclasses are below it, at least in our drawing, okay? So a subclass extends the functionality of the superclass. Which one of these here is the superclass? Okay, is it legal secretary? Is that the superclass? Okay, secretary is the superclass. This is the subclass. Legal secretary extends secretary, okay? The subclass extends the superclass. An employee can do everything that a lawyer can do. In this case, a legal secretary can do everything that a secretary can do, okay? The superclasses are on top, the subclasses are down below. We would do the same thing for lawyers, right? Lawyers is an employee, but wait, Lawyers, they're even more special. Okay, lawyers, they get an extra week of vacation. Now, wait a minute. We didn't have an instance field to just change the amount of vacation that a lawyer gets. Okay, we need to give them 3 weeks of vacation. How do we do that? We already know how to give them unique behavior. We already know how to allow them to sue. We do that by adding the new method. We want lawyers to inherit most of the behavior they employ, but we want to replace parts. Okay, we want to replace the parts with a new or slightly different altered behavior, because in this case they get more vacation time. How are we going to do that? Riddle me that, Batman. All right, we do something called an override. We override a behavior. We override a method with a new behavior. So subclasses have the opportunity to not only get everything for free, they have the opportunity to say, I like that. I like that piano I inherited, but I'm going to paint it. I don't like it. It's that wood stain thing that's so yesteryear. I ain't doing that. I'm painting it white. Okay, so a lawyer, right? It can say, thank you for that 2 weeks vacation, but I don't like it. I'm going to replace it. I'm going to overwrite it. Okay. So we have our public class lawyer extends employee. If we want to get 3 weeks vacation, then what we do is we override the method. We rewrite the method. It has to have the exact same prototype. Public int get vacation days. That's exactly as it was written in the employee class. And all I do is I give it a new behavior. Return 15. That's 3 weeks. That's awesome, right? So I want you to go ahead and complete the lawyer class, and I want you to add the method can sue, okay? This is I don't have a pause button here. You have to pause it. You have to write it. All right, it should look something like this. Lawyer class extends employee, we override the method, and then we simply add the new behavior, okay? So when you see someone, you see them in court generally. All right, that was all that I wanted to cover today. Can you believe it? You did it. We kind of learned inheritance, and we didn't really practice too much, but we're definitely going to practice a lot more. We learned that subclasses extend the behavior of the superclasses, and they can override existing behavior to be the way they want it, okay? Subclasses inherit from their superclass using the extend keyword. We also have learned that this drawing over here, that we draw arrows up to the superclass. And what we learned is that children inherit from their parents. Well, children classes inherit from their parent classes. So yes, we do use that terminology in computer science. We say that up here is the parent class, and down here are the children classes. That's it. We're going to do some more practice in a bit, but for now, I want you to stick with that, and hopefully that sticks into your head.